Good morning. Today we are going to be covering Algebra 2, Lesson 8.1, Simplifying Rational Expressions. And so what you're going to be doing is you're going to be able to multiply and divide rational expressions, and as well as simplify and factor them. Now, when we talk about rational expressions, we're particularly talking about rational fractional expressions. So I'm just going to write that. Rational fractional expressions. So what are we talking about there? For instance, let's just look at this fraction. So we've got 8 divided by 12, and we want to reduce this. So what you would want to do is you'd want to factor this. So you would look at the 8, and what could we divide that by? And the 12, what could we divide that by? So we're looking for the greatest common factor. Well, it looks like we could reduce 8 divided by 4, and we could divide 12 by 4. And so then we're going to get 8 divided by 4 is 2, and 12 divided by 4 is 3. So that's the simple way you would be doing that. But we're going to show you another way to do this. So what we're going to do is we're going to take 8 over 12. And what I would really like you to do is I would like you to find the prime factors for 8 over 12. So we'll do an upside down tree here. So 8 divides into, 4 times 2, and 4 divides into 2 times 2, and so we have a total of 1, 2, 3 prime factors here. And so that means that 8 equals 2 times 2 times 2. Okay, let's just use the little asterisk or button for multiplication. And then the 12 would factor into, let's see, 4 times 3, right? And then 4 factors into 2 times 2. So we have prime factors there. And so we would have, let's see, 2 times 2 times 3. Now, what you can do with this is you can reduce. Now, once you've got your fraction fully factored, meaning set up so that you only have numbers that are multiplied together in the numerator and multiplied together in the denominator, then you can reduce. So we would reduce 2 divided by 2 is just 1. 2 divided by 2 again is just 1. And that leaves us with 2 over 3. So that's what we're going to do with algebra and polynomials. Okay. All right. And oh, don't forget, you must upload your notes to me by 11:59 p.m. Saturday for credit. Okay. All right. So we're going to simplify the following fractions completely. And if the fraction does not simplify, then we want to submit the fraction in current form. Okay. So let's look at the first one here. We've got 99 divided by 77. Well, 99, let's see. We can factor that into 9 times 11, right? And we can factor 77 into 3 times 11. So, and then we have the x cubed here all by itself in the denominator. So this would change to, let's see, let's quickly rewrite this as 9 times 11 divided by 3 times 11. And then the x cubed is really x times x times x, right? Now let's find common factors. Well, let's see. And 9 is also 3 times 3, is it not? Oh, I'm sorry, this is... We could factor 9 into 3 times 3, but I wrote this down wrong. This is actually 7 times 11. So there's no need to reduce the 9 because we aren't going to divide a 3 into 7. So we're going to leave this like that. And so we see that we have an 11 here and an 11 here. So that simplifies to 1. And then the rest of this does not simplify. So we're just going to rewrite this as 9. 9 times 1 or 9. And then we have 7. And then we have the x's. We'll multiply them back together into 7x cubed. And that is our answer. Okay? All right, now these are all monomials that you're working with here. And the reason this worked for us, again, was we could break these down into numbers that were all multiplied together in the numerator and all multiplied together in the denominator. Okay? So let's do the same thing with b. So b, we have 81. 81 can be broken down into 9 times 9, and 72 can be broken into 9 times 8. So let's do that. Let's just change this to 9 times 9, and then we have x squared, which we're going to break down into x times x. And then 72 we said was 9 times 8. And then we have x times x times x times x. All right, so again, the 9 divided by 9 is 1, so that just is left as 1. The 9 and 8 we leave alone. And then we can get rid of x divided by x, that's 1, and x divided by x, that's 1. And so what are we left with? We're left with, in the numerator, 9. And in the denominator, we're left with 8. And then x times x is x squared. And that's a perfectly acceptable answer. And then the last one we have here, the last monomial, is 27x cubed. And 27, let's see, that's, we've got 3 times 7 there, and 24 is 3 times 9 is 27, and 24 is 3 times 8. Let's just show that here. So 3 times 9 is 27, and this is 3 times 8, right? And this is x to the 3, and this is x squared. So we can rewrite this as 3 times 9 times x times x times x for the numerator, and the denominator 3 times 8 times x times x. And so we'll do the same thing we did before. The 3 divided by 3, that becomes 1. X divided by x is 1. X divided by x is 1. And what are we left with? In the numerator, we are left with 9 times x. 1x left over up there. And down in the denominator, we are left with 8. Okay? So, perfectly acceptable answer. All right, so these are, again, monomials. Divided by monomials. All right? So you'll notice in every single case what we did was in the numerator we broke everything down into something that could be multiplied. Okay? And then we did the same thing in the denominator, and that way we were able to come up with what we could turn into 1 by taking something that was the same in the numerator and the denominator, and that divided out as a 1. Pretty simple. Okay? All right, so in this case we're going to be multiplying, and we want to again perform the operation fully and simplify fully. And so when we're dealing with two fractions, though, that these are no longer monomials, but they multiply together, so we can just multiply across, right? So 3 times 3 is, 3 times x cubed is 3x squared. So we'll just put it together, 3x squared, or I'm sorry, 3x cubed. Okay, and then we have 2x times 3, and what's that? That's 6x. So we could rewrite this as 3 times x times x times x over, and then we can factor 6 as 2 times 3 times, and then there's an x there, so 6x. That's 2 times 3 times x. Okay, very simple. We can cancel out the 3 divided by 3. That's left, leaves us with 1. We can cancel out an x divided by x. That leaves us with 1. And so our final answer will be x squared divided by 2x. Okay. Oops, we lost that x. I'm sorry. This canceled out. So we had an x cancel here and an x cancel here. So we're left with x squared divided by 2. I'll just rewrite that. X squared divided by 2. Okay? Perfectly acceptable, beautiful answer. Okay? All right. So now here we have division going on here. And if you remember with division, we have to change this around. When you can't divide a fraction, so what you have to use is keep, change, and flip. If you remember that, I think that was a middle school thing. Otherwise known as multiplying the reciprocal. All right. So we will rewrite this as 3 over 2x, and then we're going to change this sign to multiplication. Okay? And again, we're multiplying across when we get to this, but what are we left with here? Well, we're going to have to flip it. And so we're going to put in here 5x squared. And then it's going to be divided by 1. And so again, remember that you're going to multiply across here. So 3 times 5x squared. 3 times 5 is 15. And so you have 15x squared. And then in the denominator, you have 2x. And so if you'll remember, we want to factor this, so we have 15 times x divided by 2 times x, and so that's going to leave us with, let's see, we're going to lose this x and this x here, so we're going to be left with 15x over 2. All right. There's our answer. Well, this looks ugly. What is this? Well, we've got a fraction divided, so this means divided, right, by a fraction. That's called a complex fraction. That's what that is. And we want to rewrite this into keep, change, flip. Okay. So let's take the first one. So we have x cubed divided by 2. And remember, we want to keep that. And then we're going to this is divided by, we're going to change that, and then we have 3x over 2, right? So I want to change this, and I want to flip this. So I'm going to rewrite this as x cubed divided by 2, and then I'm going to change this now to multiply by, and then I'm going to flip this. So I'm going to have 2 divided by 3x. Right? Okay, now we're ready to go ahead and factor this. Now we could leave it in this particular form, but right now let's just multiply it together. So let's use 2x cubed divided by, let's see, 2 times 3 is 6x, right? And that factors into 2 times x times x times x divided by 2 times 3 times x, right? So again, we can factor out the 2. 2 divided by 2 is 1. And we have an x divided by x, that's another 1. So that leaves us with x squared, 2x, I'm sorry, 2x squared. Nope, 2 is going away. So it leaves us with 1x squared, right? This is 1x squared. So x squared. And then, and if you want, you could put a 1 in front of it, but we can just leave it like that. Divided by, and then we're left with 3x. No, we're left with just 3. Just 3. Only 3 is the only thing left there. So that's coming down from here to here, right? So this is our answer, x squared divided by 3. Okay? All right. Now, this time around, in this example, we are dealing with binomials in a lot of this, and there's a trinomial over here. So we need to factor first. So let's just make that known. Factor first. Very, very important that we factor first. And so let's look at this first one. If you look at the numerator here, that's difference of squares. Got x squared, and then you got minus 64. Both are perfect squares. So we'll write that out. Difference of squares. And then let's just go ahead and factor that down here. So we've got let's see here. Do we want to just do this? Yeah, let's do it first. So we've got, let's just do a double bubble. So we've got x in the numerator, and then we have plus or minus 8. So plus 8 minus 8. All right. And then these are factors now. They're actually multiplied together, if you can see that. So that's what you want in the numerator. Okay. And then the denominator now, it looks like we've got a greatest common factor we got to get rid of. And what is it? Looks like we have x cubed here. So it looks like we can factor out the x cubed. Right? So x cubed. So we're going to do that. We're going to write that down here as x cubed out here times, and then we've got looks like we're left with x to the 1, so x, and then minus 8. Okay, so again, these are all factors now. They're all multiplied together as factors. That's what we want in the numerator and the denominator. Now, since they're fully factored, then I can look for what's the same in the numerator and the denominator. So I've got an x minus 8 up in the numerator and an x minus 8 in the denominator. So that whole bubble in each of those goes away because they're multiplied. Now, I can't take the bubbles apart, so you be careful about that. The pluses and minuses are strong bonds. You can't get rid of them. But if they're multiplied together, so I've got a group of them multiplied together, you can take the whole groups out. That's what we just did here. Now I'm left with x plus 8 in the numerator and x cubed in the denominator. So I just write that out. So this equals x plus 8 divided by x cubed. Now, could I have left the x plus 8 in parentheses? Yeah, but you don't need it once you have them by themselves like this. So this is a perfectly acceptable answer. Okay. All right, so in the next one, I've got 7x divided by x squared plus 4. Now, it doesn't look like I can do anything with the numerator because 7 is a prime number and x is by itself. They're just multiplied together. X squared plus 4x, I've got a GCF there. I can factor out an x. All right, so I'm just dividing by x here. I'm dividing by x here. You can think about it that way. Then you can see where we're going with this. So I'm going to rewrite this as 7 times x in the numerator, and the denominator I'm going to be left with, I'm factoring out this x, so I'm going to have x times, and then I'm left over with an x plus 4. Okay. All right, so what can now this is fully factored up here because the 7 is multiplied to the x. This is fully factored down here because the x is multiplied to this group, x plus 4, which stays together. All right, so what can I divide out of the numerator and denominator now? I've got an x up here and an x down here, so those divide out as 1. X divided by x is 1. So I'm left with 7 divided by x plus 4. And again, you can take the x plus 4 out of parentheses. Perfectly acceptable answer. All right. Well, here I've got two trinomials. All right, so I'm going to have to double bubble these. So let's do that. So let's see, that's going to equal parentheses and so first I've got x squared, so I'm going to have x and x in the beginning of it. And then what times what equals negative 28 that when added together equals 3. Let's see, so I've got negative 14, and negative 2, or positive 2, negative 14 and 2. I've got negative 7 and 4. I got 4 and negative 7. Oh, so 4 and negative 7, I think, is what we want. No, negative 7 and 4. So negative 7 and 4. So this one. So negative 7, positive 4. And we want to make sure that that works, so we're going to go ahead and kind of do the old rainbow thing, if you remember we did that. So we have 4x and negative 7x, and those add up, let's see here. Is that what we want? 7x. We want positive 7x. And we're going to have negative 4. So this is why you do the rainbow, to make sure you got it right. So 7x and negative 4x, 7 minus 4 is 3x. So now we know we got it right. All right, so that's the first one. Now the second one, so we have x and x, and then what times what equals negative 32? That when added together equals positive 4. So 16 and negative 2, negative 8 and 4, negative 4 and 8. 8 minus 4 is positive 4. So negative 4 and 8. Positive 8. And so again, do the double bubble thing here. And so you know that you've got 8x minus 4x leaves you with positive 4x. Okay, so let's clean this up now. You've got in the numerator, you've got an x minus 4. In the denominator, you've got an x not minus 4. So that leaves us with one of those in the numerator and one of those in the denominator. And so you're left with x plus 7 divided by x plus 8. Now just remember, you cannot, at this point in time, the numerator and the denominator are addition problems. They're unlikes. You've got to leave them like this. You cannot break these bonds. You cannot divide out x and x. You can't do that. It's because a plus or a minus are strong bonds. You want to leave them alone. So don't cross off x's. All right? When you have plus or minus. Okay? Just make sure you do that. All right, so we're only doing these when we've got things multiplied. We had things multiplied here and here. So that's why we were able to get rid of these. We had multiplied here and here. That's why we were able to get rid of these and so on. Okay? All right. Looks like 2 left. So these are multiplication problems again. And what we want to do here, we've got to perform the operation that we see here. So perform the operation and simplify the answer fully. Okay. So over here, before we do anything, we got a GCF here, and over here we've got a factor. Okay. So let's GCF this, and this one we want to factor and reduce. Okay. And so let's go ahead and do that. So we can factor out what out of this? We can factor a 3, so that's going to leave us with 3 times x plus 8, right? And then we got an x minus 1 in the denominator, and you can't do anything with this. Remember, you cannot do anything with this because it's added, subtracted, you can't, in this case, subtracted. There's no factor to multiply to, okay? So we've got to leave it just like it is. All right, so that's going to be times. All right, now this we have to factor, and what do we got? We got difference of squares. So that can factor into double bubble. And so x and x, and then what times what equals negative 4, positive 2, and negative 2. Okay? So now, fully factored. All right, and then now we have to go ahead and factor the denominator. And so let's see here. Times what equals negative 16? Negative 4 and 4. 8 negative, 8 negative 2. We could use 8 negative 2. Factor 8 negative 2 because 8 minus 2 is 6. All right? So we're going to set this up as, again, x squared is x times x. And then we're going to have positive 8 and negative 2. And then don't forget, double bubble it just to make sure. So x, so that's negative 2x and positive 8x. 8 minus 2 leaves us with 6x. Okay. All right, so let's clean it up. We have, well, let's just write it. Now we don't have to rewrite all of this if you can see this just from what you're doing and start to make your factoring out your numerator and denominator. But let's just, for the heck of it, put this all together mathematically in the next step. So x plus 8, 3 times x plus 8 times x plus 2 times x minus 2. Okay? And in the denominator, we have x minus 1. And we'll put this in parentheses now. Times x plus 8 times x minus 2. So you see now we have multiplication all the way across the numerator and all the way across the denominator. Again, don't go inside the groups where they have pluses or minuses. You can't do anything individually in there because those are strong bonds. Do not change those. But let's see. I've got an x plus 8 in the numerator here and 1 in the denominator. That can reduce to 1. I got an x minus 2 in the numerator here and 1 down here in the denominator. So what am I left with? Looks like I'm left with 3 times x plus 2 divided by x minus 1. Okay? And that is our answer. Okay? All right. Oh, division problem. What are we going to have to do here? We're going to have to keep, change, change, and flip, right? Keep, change, and flip. All right, so let's do this. So 7x cubed, we can factor that out into 7 times x times x times x, right? And down in the denominator, let's see, we can factor it into double bubble. So x and x. Now, what times what equals 30? Negative 30. That when added together equals 1. Okay? So, let's see here. Negative 3 times 10, obviously. How about negative 5 times 6? Okay, so here, this will work. 6 minus 5 is 1. So I'm going to have negative 5 and positive 6 in my factorization here. Okay. All right, and so now I'm going to flip. Change rather. I'm going to change this down here to multiplication, and then I'm going to flip, and let's see here. So these are going to reverse, right? And so if I reverse this, I'm going to have x squared minus 36 in the numerator. Now, this is difference of squares, right? So we can just set this up as x plus 6 times x minus 6. So x plus 6 times x minus 6. And then what do we have up here? We have x squared minus 6x. Now that's a GCF thing, right? Yeah, so GCF, this one. So we're going to factor out an x, and we're going to be left with times x minus 6. Okay. All right. So now, having done that, you can see you've got, where's my pencil? Here it is. I've got an x minus 6 in the numerator, and I've got an x minus 6 in the denominator that can go. And now, I could multiply this all together like I did down here, but you can kind of see this as one problem. So I'm not going to bother to do that now. Just a shortcut, if you can do it. I got an x plus 6 here, and I got an x plus 6 here, right? And then I've got an x here, and I've got an x here. So I'm left with I've got 7x squared in the numerator, and then in the denominator I have x minus 5. Okay, so that's it, ladies and gentlemen. We're done with this, and have a great rest of your day. Thank you. Bye-bye.